Hello everyone, welcome to the Viral Coder. Today we are going to solve a problem which is known as Alice Library. This problem is posted at various websites which provides competitive programming platform. If you search the solution of this problem, in most of the cases you will see that they are implementing a stack data structure. This problem can be solved by implementing a stack data structure, but we have a different approach today. We will solve this problem by using string manipulation functions and algorithm of standard template library in C++. Let us move toward problem statement. It says that Alice is rearranging her library. She takes the innermost shelf and reverses the order of books. She breaks the wall of the shelf. In the end, there will be only books and no shelf walls. Print the order of books. Opening and closing walls of cells are shown by forward slash and backward slash respectively, whereas books are represented by lowercase alphabets. Input format. The first line contains a string S displaying her library. There is only one line of input which is a string and which displays her library. Output format. Print only one string displaying Alice library after rearrangement. So there is only one line of output also which is a string and which represents her library after rearrangement. So there is one line of input and there is one line of output, both are string. There is a constant also which says that the length of S is greater than equal to 2 and is less than equal to 10 to the power 3, which is 1000. There is a note also. The first character of a string is forward slash and the last character of a string is backward slash, indicating outermost walls of the cell. So the first character and last characters are forward slash and backward slash respectively, which indicates the outermost wall. There is a sample input given. Let us understand this. This is the sample input and this is the sample output. So how this input is transformed into that output? Let us understand. The problem says that she takes the innermost self first and then reverses the order of books and then she breaks the walls of self. Okay. So what is the innermost self in this? This is the innermost self, right? This is the innermost self. So this will be reversed first, not the walls, the content under the walls, the content inside the walls. So this will be reversed first and then the wall will be broken. So it will become forward slash u forward slash evol backward slash I and then backward slash. And then the walls will be broken. So this will become this string. Okay. Now the innermost self, there is only one innermost self left. So again this content inside this will be reversed and wall will be broken. So it will become like this and then wall will be broken. So that is how the input is transformed into output, right? We have to take the innermost self first, we have to reverse that and break the wall. Okay. There is also a time limit of 2 seconds and there is also a memory limit. Let us move towards the coding section where we will see how we will solve this problem. What is our approach? We will solve this problem using C++. So I will include IOStream, and then I will include string. I will include a string and then I will include algorithm, which is a part of STL, right? I will use a namespace. We have a main function, right? I will comment down the sample input which was given for simplicity purpose. Okay, first we have to do is, the first thing we have to do is, we have to take a input line which is string. So I will declare a string variable and I will input a string, right? So for solving this problem, we will assume that this is the input. Now we are assuming that this is the input. So if you see that we have to reverse this thing first, the innermost self. The content of innermost self will be reversed first. How we will find the innermost self? So we have to find the last of forward slash and the first of backward slash. What is the last of forward slash? This is the last of forward slash and this is the first of backward slash. So between this our content resides. So the innermost self can be found by finding the last of forward slash and first of backward slash. So we will do that, right? I will declare two variables x and y which will hold the position of backward slash and forward slash. So first I am going to find the last position of this forward slash and store it in x, right? So there is a function which says that find last of. This function finds the last occurrence of a specific character. So we have to find the last of this character, the last occurrence of this character in a string s, and we have to store it in x. So in this input, if consider this input, the value of x will be 0, 1 and 2. At second index we will find the last of forward slash, because after that index there is no any forward slash, right? After that index there is no any forward slash. So the value of x should be 2. So let us print and see that whether it is correct or not, whether we are finding the correct index or not. So I will return an integer. I will save this program as ls library .cpp and I will execute it. I will give the same input as given in the sample input, u lb then I. Okay, so the value of x is 2. So the value of x is 2. Now we have to find the first of backward slash, the first of backward slash. So for that purpose we have a function which says that find first of. It will return the position of a specific character, the first occurrence of a specific character. Okay, so we have to find the position of first position of backward slash. We have to proceed the backward slash with another backward slash because backward slash is a escape sequence. You have studied about escape sequence in the basics of C++. Backward slash is a escape sequence. We use some other characters with that, such that backslash n, backslash t. So we have to precede it with another backslash. Okay. So what this function will do, that it will find the first occurrence of backward slash. So let us print y also and see out and y. So what is the first occurrence of backward slash? Here is the first occurrence of backward slash, right? So count the indexes 0, 1, 2, 3, 4, 5, 6 and 7. The answer should be 7, right? So let us, let us compile and run. Two and 7. The value of x is 2 and the value of y is 7, right? Right. So now we have find the location of innermost self. Okay. Now we have to reverse inside. We have to reverse the characters. We have to reverse the substring inside this range, right? So for this, now I am removing this cout line. Okay, for this we have a function. We have a function which belongs to STL algorithm, reverse, right? This reverse function takes two arguments, which is a starting point and ending point. So what is the starting point? We have to reverse from L. We have to reverse from L, not from this forward slash. We have to reverse from L, right? So I will give the starting position as s dot begin. S dot begin, it points to this slash, this forward slash, right? S dot begin plus x plus 1, right? Plus x plus 1. So let us see s dot begins, which means we are here, plus x plus 1. X means in that case 2, 2 plus 1, 3, right? So it will move forward 3 times. So first, second and third, it will point at L. From L to E. From L to E. Now we have to give the index, give the position, last position. So s dot begin plus y. Here we don't have to put y plus 1. We don't have to put y plus 1 because reverse function takes the first iterator. It starts reversing from the first iterator to the last position minus 1. Okay, so s dot begin plus y means 7, so it will move forward 7 times. 1 and then 2 and then 3 and then 4, 5, 6 and 7. So it will leave this slash. Okay, it is starting from L and ending to E. Okay, it will leave this at the last position. The reverse function leaves this. Okay, so we have to reverse, right? And now I will. Okay, and now we have to break the wall also. So from now our string, innermost string has been reversed. We can check that. Okay, I will compile that and I will run that. If you see, the string has been reversed. Now we have to break the walls, right? We have to delete. We have to just delete it. We have to just delete it. We have to delete the last of forward slash and first of backward slash. So we will delete. So for deleting, we have erase function. S dot erase. Okay, erase. S dot erase. And we will give the position. So the same position, s dot find last of, and we have to delete one character, right? And then s dot erase find first of, and we have to delete again one character, right? It will delete, and now we can print this. So if you see, we have successfully reversed the content of innermost wall and we have broken the walls, right? See the output, right? Now the same step will be repeated. Until when? Now the question arrives that until when? This steps will repeated until when? So I will put these codes into a loop. Until when? Until you find, until you doesn't find the pattern anymore, right? What is the pattern? Pattern is forward slash, then some contents, and then backward slash, right? This is the pattern. So when you don't find the pattern, you have to we have to close the loop. So what I will do is I will run a while loop, infinite of while loop, right? I will break this while loop by using some conditions, right? So note that this find last of and this find of functions return -1 if it doesn't find that character in the string. The find first of and the find last of returns -1 if it doesn't find that character in the string. So if it doesn't find any character like that, which means our task has been done. We have successfully solved the problem. So till when we have to repeat these lines of code? until until we do not find these characters anymore. Okay, so if there is no any forward slash in our string, so we have to break the loop, we have to exit from the loop. So if x is equal to -1, right, we have to break, right. And also suppose there is a string which contains this forward slash, but if some string doesn't contain this backward slash, then also we have to break the loop, because this loop will only execute if we find both forward slash and backward slash, right. So if there is no any forward slash and backward slash, then we do not have to execute this loop. This loop will only run when we find a forward slash and backward slash, right. So if any of these two is missing, then we don't have to execute this loop, we don't have to continue this loop. So if suppose that in a string it contains this forward slash, but it doesn't contain backward slash, so we have to break the loop. So same for y, if y is equal to -1, right, then we have to break also. Okay, now let us run this. Okay, I'm running this. \u /lob, sorry, /u /lob /i /, and then that's all. That's our output, how we desired. So let us see in another example also, another input also, as a t, is, and then h. See that we do not, according to the question this is wrong input, right, according to the question this is wrong input, because we do not have provided this forward slash backward slash at the end. Let us take another input. Okay, as a t, is, and then h, and then, so this is the correct input according to the question, because the question says that the input must contain the forward slash and backward slash at the first and last position respectively, right. So first this is reversed as s and I. Okay, I think this is given h will be at first position, then again this will be reversed as I, and then s, and then t, and then a, and then s. It is right. So the same problem can be solved using stack data structure also, but we have solved it by using string manipulation functions and a standard template library. So this reverse function is an algorithm of a standard template library. So this is how we use find first of function, find last of function, and reverse function, and erase function. So in this program, you have learned using find first of function, find last of function, reverse function, erase function. Thank you very much.